Okay, so welcome everyone. As mentioned, my name is Michał Bendowski. I work on Android Studio in London, mostly on the parts related to the build system. So today I would like to talk to you about how Android Studio interacts with the build system, and why that should matter to you, and how you can use this knowledge to possibly improve your build times. So if you've used Android Studio, and actually speaking of which, can I get a quick raise of hands? How many of you have used Android Studio? Okay, most. That's not a surprise, I guess. How many of you know the difference between a flavor and a variant? Okay, not everyone, but most. And how many of you know what a class loader is? Oh, actually more than I expected. So great, a technical crowd, awesome. Okay, so you've used Android Studio, so you know that we depend heavily on Gradle for building the projects and also for organizing projects and understanding how they are structured. So let me start by talking about how that works under the covers. And more specifically, how does Android Studio work with the Gradle daemon? So daemon is a feature of Gradle which works the following way. Whenever you invoke Gradle in the daemon mode, the foreground process that you start, instead of running the whole build inside of it, will instead spin up a new process running in the background and then pass all the invocation arguments to the daemon process. Then the daemon performs the actual build and streams the textual output back to your foreground process so you can print it out to the console. Now, eventually, the build is finished, at which point the foreground process dies. But at some point in the future, another Gradle invocation may come along, either for the same project or a completely different project. So as long as certain basic criteria are met, so the same version of Gradle, the same version of the JVM are requested, the new foreground process will find the existing daemon and connect to it, and again, send all the invocation arguments there, wait for the output, print it out to the console, and die. So those foreground processes come and go, but the daemon stays running, and that is important, because being a long-running process, the daemon can take advantage of some internal caching, and the VM that is running in can do the same, so that the longer the daemon runs, the more we understand about its execution patterns, and so the JIT compiler can do a better job at optimizing it. So you probably guessed by now that Android Studio will follow the same pattern, so it will use the Gradle daemon for both syncing and building, and I'll cover syncing a bit later in the talk. And actually, on top of that, we are forced to use the daemon. Because we use the Gradle tooling API, it forces us to always perform any kind of Gradle-related builds out of process. So we will always use the daemon in the background. Although one difference between invoking Gradle from a command line and Studio is that Studio itself is a long-running process, so the daemon can die underneath it, which is actually quite common because the daemon is configured to shut itself down after a certain period of time, so that if you notice that the very first build in the morning after you come back to the office is slower than usual, that's probably the reason for it. So in such a situation, Studio will spin up a new daemon for the next build. And it's also maybe useful to know that if Studio finds an already running daemon when it starts, it will happily connect to it and use it. But if for some reason Studio is forced to create a new one, it will make sure the daemon is shut down when Studio quits. So the takeaway is that if you only ever run your builds from Studio, you don't have to worry about the daemon running in the background and eating your resources. OK, I mentioned build performance briefly. If you were to actually try running a couple of builds on your machine using the daemon mode and not using it, you would notice a similar shape. So that without using the daemon, the performance is very reproducible from the very start. If you do use the daemon, you would notice that the first build usually takes around the same amount of time. Then you get a noticeable improvement in the second build. And then it still takes a couple of them, usually around 5, for the performance to fully stabilize. So if you ever want to benchmark your build speeds and experiment with different versions of Gradle or Studio or JVM, please make sure to discard the first couple of builds, just so your variance is not too big. OK, so I mentioned syncing, and you must know this from practice. So whenever you change any of your build scripts, we would show a bright yellow bar at the top of Studio, nagging you to sync. Studio really doesn't like being out of sync. So what exactly does it mean? So syncing is the process in which we ask Gradle to run all the build script logic and execute the whole, how it's called, configuration phase. And once this is done, we invoke the Android plugin to construct a description of the whole project as we see it and as we would use it during build. And this description, the Android project, or an object of Android project type, is sent back to Studio. So the way this is implemented is that Studio actually instantiates an object of type build action, which is an interface. And we send this object to the other VM, the daemon. It then runs inside the daemon VM against some specific Gradle APIs. It then constructs the Android project result, the answer, which it does by invoking the Android plugin. And then the result is sent back to the IDE. So you may be wondering, how is it possible that Studio can inject or arbitrary code into the daemon to actually construct the result, and then how the daemon can return a proper, fully working Java object back to Studio. So this is not just some serialized data format that gets sent, it's a proper Java object. So I find it quite interesting, so let me talk briefly about it. So we haven't written any of that code, that's all handled by Gradle, but I think it's good to know. The way this works is that Gradle will look at the object in question. It will find its class. It will look at the name of the class. Using the name, it will find the corresponding resource, so that this way it finds the bytecode for the class. Then Gradle will analyze the bytecode, looking for references to other classes in the constant pool. And using those names, it will again find the bytecode for those classes and repeat this process recursively until it reaches some kind of transitive closure of this relation. And the net result, I guess, is that you construct a minimal necessary class path to instantiate the object in question. And then the tooling API gets this class path, this list of jars, and sends it to the other VM together with the serialized object. And then constructs a separated class loader, which uses the class path sent. And inside this class loader, it deserializes the object. And at this point, because the class path is set up correctly, the VM verifier is happy with that. And on top of all of that, because the object lives in a separate class loader, there's a layer of runtime proxies that make it work. And through these proxies, the object is actually exposed to the rest of the VM. So generally speaking, it's not a trick you see every day. So if any of that sounds cool to you, it does sound cool to me. I suggest you have a look at Gradle source code. Those guys are definitely not afraid of using reflection and other similar tricks. So yeah, highly recommend it. Once you've seen it, you never look at the Java programming language the same way ever again. OK, so what exactly is the data that we're getting through syncing? So obviously, these are the basic properties of your project, like the compiler SDK version, the min SDK version, the version of build tools, your application ID, which translates to the package of the APK, and so on. Actually, on the right on the slide, you can see the so-called Android model window that you can see in Studio on the lower right corner. I'll try to show it to you in a second. But these are the kind of things that Studio will then use to point the code completion engine to the right platform jar. It will use the application ID when starting your application for ADB. It will configure lint to use the right min SDK version, and so on. If you ever find yourself, I guess, confused about, oh, sorry, the title is wrong, but if you ever find yourself confused about the layout of your project, you can use the source set task, and it will actually print out a bunch of details about how your project is structured. That's just a side note. Another, I guess, piece of information that we get during syncing is the whole dependencies information, so that Gradle, being the enterprise-ready build system, which it is, it has a whole machinery for managing dependencies. So you can actually you can manage transitive dependencies. You can exclude some of them. You can enforce certain versions. You can provide a custom strategy for resolving conflicts. You can check the Gradle documentation for details. But the point is that once you and Gradle agree on what is the actual dependency graph that we're supposed to use, then the Android Gradle plugin will use it, and we'll also send it to Studio, so that the plugin and Studio have the same, they have a consistent understanding of what dependencies you're using. And on the right on the slide, you can see if you change your project view from the so-called Android, I guess, mode to project mode, you should get the external libraries node, and then you can expand it to actually explore all the libraries that we've decided the project will use. You can also look inside of those. Also, once sync is done, all the dependencies have been downloaded or otherwise located on disk. And also in the case of AARs, like the support v4, note here, AARs are extracted so that the jars inside of them are already on disk, so we can point the code completion engine at them. By the way, The reason why some AARs end up having more than one jar inside of them, AARs stand for Android Archive, is the way we distribute Android libraries, is that if you ever have a local dependency for your library, then because we don't know if the same code can be downloaded from Maven or JCenter, then we have to package this dependency inside the AR so that your users can have access to those classes. So that's what happened here. The internal impl jar was the local dependency of support v4, and it ended up being distributed together with it. Okay, if you ever find yourself, I guess, surprised by which dependencies your project ends up using, these are two Gradle tasks you may use to debug it. One comes from Gradle, the second one comes from us, and should give you a somewhat more readable output for Android projects. Lastly, there's also, in every project, there's a top-level settings.gradle file that describes how your project is structured on disk. You can use this file to actually change this layout. So in this example, I've chosen to put all my application projects under apps. And Studio understands this and picks it up. One reason you may want to do that is to work better with your version control system. So if you want to, for example, keep your sub-projects in different repositories using Git sub-modules or something like that, and then version them separately but build them together, if that's your thing, you can do that. Okay, so there are actually a couple of more things you can customize in a project. So let me show you that real quick. Here I have a Studio running in presentation mode, and that is the default project. I'm sure you know it by now. The Android model window that I mentioned, you can find it here. So this is a tree view that more or less renders the Android project object that I mentioned before. You would see that this is the build folder that Studio expects to find all the artifacts in. This is the build tools version, the compile target. It all matches what I have here. You would also see that I have two variants currently, the bug and release. So let's change this a bit and see how that works. So I'll save you the view of my typing skills and just uncomment parts of it. So first of all, I'll declare some product flavors. Most of you seem to know what flavors are. What not everyone knows is that you can define custom flavor dimensions. So in this case, I'll declare two, price and data. A typical use case for flavors is to declare a free and premium, I guess, versions of your applications, so that the premium one can have more features. Another useful trick is to have a version that uses mock hard-coded data and one that actually connects to your backend. So you can use the mock version for testing, for example. Now, on top of that, we have a feature called variant filter. So you can use it to actually filter out some of the combinations. And speaking of which, for those of you who don't know what's the difference between a flavor and a variant, because now I have 4 flavors, and I still have 2 build types, like the bug and release. That gives me 8 possible combinations of all of those features, and those combinations we call variants. So generally speaking, you can build 1 APK per variant. But in my case, actually not all of the variants make sense, since it doesn't ever make sense to make a release APK that uses mock data. So using the snippet here, I'll just filter them out and reduce the number of variants to 6. Also, we have a feature called variants API. So I can use it here to actually modify the variants a bit. So in this case, I'll loop over all of them. And for every output, in our case, there will be only one output, the APK. I will change the name of the APK to contain some string. We'll see how that works in a second. And by the way, some people are really tempted to put something like a dynamically generated value here, like a timestamp or a release name or possibly like a Git commit version. That may be a good idea for release builds, but please understand that Studio doesn't understand that those things are generated dynamically. So if it's possible, the value of your function will differ between builds so it will differ after the sync is done. Then Studio will look for the APK in the old location, the one that was current at the time of the sync. And in the better scenario, it will just not find it and die. Well, not die, but fail. In the worst scenario, it will actually find the old APK, and you'll be wondering why your changes are not visible. And lastly, let's play with the source sets a bit. So Gradle is very dynamic. So if, for example, you find yourself confused by the fact that The Java style resources are always under the resources directory, and the Android style are under res, and you find it confusing. You may change the name of the directory in which we'll look for resources. Okay, so let's sync now and see what we get. Okay, so now, if we open the build variants window here, you will see that I have 6 variants instead of 2. You also see the 2 that I filtered out are not here. Studio has this concept of an active variant, which only enables the source directories that are applicable for a given variant. Obviously, that's a limitation of the IDE. Eventually, we want to arrive at the point where we understand the whole model, and you can use just the right classes in every file. But for now, that's something that we're working with JetBrains on. And for now, you have to choose which variant you're currently working on, and that enables the right source directories in the IDE. On the other hand, if I come back to the Android model view, you'd see that, yet again, I have all the variants here. I have 6 of them. And if I look into some of them, I will find, I will look at artifacts, main artifact. I will see the sources. And here, for example, you can have a look where the IDE will actually look for your sources. So for every variant, currently there are 6 different places where you can put your sources. Most of them will probably go into main, but you can have premium-specific code that would go into here. The hard-coded mock data parts would probably go here. The other combinations probably don't make that much sense to you, but they are there if you need them. You may also notice that resources directories, there are also 6 of them, and most of them use the resources name, but the main one uses Java resources that I configured over here. Okay, let's actually go back to the presentation. Okay, so that's what you can, I guess, achieve with build file customization and how Gradle interprets it. So let's change the topic a bit and ask how many processes does it take to build an application? So I'm sure there's a great joke waiting there, but as of Studio 2.0, the right answer is that you need around 3 types of processes and probably 6 of them altogether. And the reason for that is that obviously you have the Studio itself, which you can see. As mentioned, Studio always relies on the daemon to perform any kind of build, so that's the second process. And currently the daemon treats the DX compiler, which heavily dominates the build times for pretty much every application, as a black box. So it spins it up as separate processes in the background. And usually we spin up a couple of them in parallel in an effort to decrease your build times. So now that you know how many processes are there, the good question to ask is how you can allocate resources to them so you can try to make your build faster. So to look at Android Studio process, you can actually enable what's called like a memory indicator. If you're ever curious about how much memory Studio uses, you can also click it to force garbage collection in the Studio JVM. And to tune any kind of JVM flags that Studio uses, you can use the help menu and choose the edit custom VM options item, and that will help you create a file that will be then used by the Studio launcher script for actually launching the Studio JVM. So some people make a hobby out of experimenting with different garbage collectors and so on and so forth for running Studio. The Gradle daemon doesn't have a UI, so it's not that easy, but you can still have a look at how it's invoked using your standard OS, I guess, diagnostic tools. So you can see that I believe 1 gig of heap size for the daemon is the default. You may want to change it, or you may want to profile how much memory it actually uses. I'll come back to it in a second. But the way you can customize the amount of resources daemon uses is using the Gradle properties file in your top-level project directory. So you can specify the JVM arcs over there. And probably the heap size will be the most important one. And also as a side note, if you really want, you can run the daemon in debug mode, which would mean you can connect a remote debugger to it. If you ever need to debug like some non-trivial build logic, you can do that. You can just set up a breakpoint inside your plugin or your build source code and then run the daemon, and you should hit that breakpoint. That's actually how we develop the Android plugin. So that's a useful trick. And for DX, the way you would look into how DX is used is you would run your build with the --info flag. Either from the command line or in Studio, you can go to a settings pane, which allows you to set custom flags for invoking Gradle. And then you would see quite a lot of output. But among other things, you will also see a line like allocated DEX executor service of size 4. So that basically means that we'll use up to 4 DEX processes at the same time. Also, you would see when one starts, you would see the Java arguments it's getting, and also the application level arguments like num threads. So that's another value that should be of interest to you. And the way to customize those values is the dex options block, where you can choose the number of threads and processes that we run at a given time. So you'll have to experiment with those values on your machine and try to pick a value that works best for you. One new thing in version 2.1 of the Gradie plugin is that we're starting to run dex in process. So there's a new flag there called dex in process, and it's actually enabled by default as of beta 3, so you don't have to enable it explicitly. But one thing to remember is that the Java heap size of the DX processes no longer applies, because now the diagram looks like this. So the DX code runs within the Gradle daemon JVM, which probably means you should increase the maximum heap size of the daemon itself. And as I mentioned before, because the daemon is a long-running process, like all those DX instances, they take advantage of the JIT compiler, knowing more and more about how they work, and they can also share some caches, so that's good. And in general, I highly recommend you actually try it out in 2.1. The Dexing in process can speed up build times up to 10 times, so that's really noticeable. Please also give us feedback if that works for you or if it doesn't work for you for some reason. OK, so how many ways are there to build an APK, and why some of them are slower, why some of them are faster, and how can you control which way Gradle chooses when building your project? So the most simple and, I guess, classic way to do it is to take all of your dependencies as well as your class files and then give them all to one huge dex invocation, dx invocation, which produces the final dex file, which then ends up packaged in your APK. So you can actually get this model by specifying the predex libraries flag to be false. And you may want to do this if you have very few cores, or if you only ever do clean builds, like, for example, on a Jenkins box on a continuous integration server, that may actually improve your build times. But instead, what we do by default is we do predexing. So that means that for every jar that you depend on, we will actually create a separate dex file. We will also create one for your classes, and then we'll invoke dx once more to merge all of those dex files into the final one. So you may be wondering, why is that any better? In this example, there will be 4 dex invocations instead of 1. But the point is that all of them are smaller, and they can be run in parallel, the first 3 at least. And on most machines, that actually gives you an advantage. And then the merging step should be relatively fast, especially if you're using latest version of build tools, so 23.02. This is where we fix the merger to be a lot faster than it used to be. And the key point also is that we care about the incremental case. So whenever you actually edit your application code, what we want to do is we only want to redex one of those files and then merge it quickly with the others. You may notice that if you use progart, your build time should decrease. The build time should increase, and that's because the way progart is wired with the rest of Gradle is that all the classes, all the class files, all the jars are fed into progart, which produces one huge jar file with all your classes optimized and obfuscated and so on and minimized. And then this jar has to be redexed every single time. So that's why the build times using progart are actually worse than without it. So if you can avoid it for using progart for debug builds, please do. Also in 2.0, we have, I guess, an answer to this problem. We introduced something called a shrinker, or the built-in shrinker. So that's an alternative to progart. It's a mechanism built into the Gradle plugin. You can enable it by saying minify enable, but use progart false. We chose the flag name, so we don't have to give a name to our solution. But anyway, the idea of shrinker is that it only does the shrinking part of progart. It doesn't optimize, it doesn't obfuscate, but it should do it faster, and it also supports incremental builds. So after every run, it stores the incremental state, and then uses this state as much as possible for further runs. So the idea is that it will be faster. It also understands the Gradle pipeline better than progart. So we know that there are, like in this case, there are 3 streams of bytecode, and we preserve this structure so that in the incremental case, again, we have to redex only one of those dex files. We'll probably try to enable shrinker by default in debuggable builds in the future. Please try to use it and give us feedback if it works for you or if you find any bugs. It should be a drop-in replacement for progart. It uses the same configuration flags and so on. OK, I guess one other option is to build an APK is to use the Jack compiler. In the 2.1 release, which is already in the beta channel, we actually improved the support for Jack noticeably. So Jack is just a one step which takes all your dependencies on your source files and produces the dex file. Right now, we are very interested in any kind of correctness issues, so please try it out and let us know if you find any bugs. The integration of Jack and Gradle is a work in progress. It should get faster in the near future. But yeah, I wanted to mention it here. And again, my personal appeal, please try it and let us know how it works. And lastly, I guess one cool trick is to take advantage of native multidex support. So if we know that the device you're targeting is at least version 21, we can take advantage of multidex, in which case there's no need to merge the dex files. So the incremental case is the best we've ever seen so far. That is, we only redex one file, and there's not even the need for merging. OK, so let me talk about Instant Run and how it combines the ideas I've talked about so far into what we have in Studio 2.0. How many of you have actually tried Instant Run in Studio? Most. Does it work for you? How many people find that it's actually improved their build times? A couple. Actually, so we know that for certain projects, it doesn't, like some people don't take the full advantage of it. Please file bugs if you find this. We'll try to find the reasons why that is the case. OK, but let me describe how Instant Run works from a high level. Before, when I was talking about the daemon, you may have gotten the impression that the whole point of the tooling API is so that building from Studio and from the command line is totally equivalent. And that is indeed the promise of the tooling API and Gradle in general. And that is an illusion we like to keep. But in reality, we cheat a little. So that whenever Studio invokes the daemon, we inject some additional properties to the invocation, so that the Android Gradle plugin, it knows when it's being invoked from Studio. And we cheat a little. So we know when Studio calls us. We know when Instant Run is on. Also, Studio will nowadays ask you which device you want to run on first before actually calling Gradle, so that we know the API level of your target device and the screen density of your target device. So we can take advantage of native multidex, even if your min SDK level is lower than 21, for example. We will also not package resources for screen densities that don't apply to the device you've chosen. So I guess one takeaway from that is that don't ever try to distribute APKs that Studio leaves in your build directory when you just work with it, because it will not contain certain resources. It will also cheat a little. It will use features from higher API levels and so on. So the proper way to actually get final APKs is use the build menu in Studio to either just say, well, generate APK, or even better, generate signed APKs, which should guide you a bit with the signing process. OK, so but what is the actual story in Instant Run? If you run it against a device that is relatively modern, so supports multidex, what happens is the following. So the only dex files that are packaged in the APK directly is the Instant Run support code. If you were to look at the manifest that ends up in your APK, you would see that the application class used is called Instant Run Bootstrap. So we're not using the default application. Then all of your dependencies are predexed. And your application code is sliced into 10 currently slices. So it's input in those 10 buckets. We create a separate dex file for every one of the slices. And then those slices, together with the dependencies, are put in a zip file. And then this zip file is put inside the APK, so that when your application starts, the bootstrapping code from Instant Run will unzip the slices and all the other dex files from the Instant Run zip file, put it on your data partition, and set up the class loaders appropriately, so that the code from the dex files are recognized by the application. So Instant Run, generally speaking, has two ways of improving your deployment time. What is called cold swap, and it's a bit simpler. And the idea there is that whenever you change any of your classes, we know which slice it ends up being in. So we just redex this one slice, and we don't even have to package the APK. What we do is we send this dex file directly to the device, to the data partition, to the place where the application expects to find it when it starts, and then we restart the application. So the next time the application restarts, I'll skip over some details of what's going on there, but it will find that there's no need to unzip the slices from the APK because all the timestamps match. And on top of it, one slice is even newer than the APK, and that's great, and it will just start running using the new code. So that's a simple case, but the most instant case of them all is what we call hot swap, and it relies on a trick. with rewriting your code. So what we do is for any given class and any given method, like in here I have activity and some helper method foo, what will happen is we put an additional static field in the class. It's called change, and it has this incremental change type. And then every single method in your class, we add an additional like preamble at the start to say, check if the change field is null, which it is by default. And if it is null, then carry on as usual. But if it's not null, then ignore all the code that you typically had in there, and instead dispatch the name of the current method, the arguments to it, and also we would send this object there as well, and just return whatever the incremental change object decided is the correct result. So the way we use it is that whenever you change any of your classes, we find only the change class files, and we create those very, very tiny dex files, which only contain one class. And then we push those tiny dex files to the running instance of your application. So I guess I should have mentioned that instance run compiles a socket server into your application, and then it starts the socket server, and Studio connects to this socket whenever it needs to do a hot swap. So whenever you see the lightning bolt in Studio where you're using instant run, that means that this connection is actually active and it's working. So Studio will take the dex file, it will push it through the socket to the running application, and then the application itself will then write the dex file to the data partition, create the necessary class loader, make sure the class is there. And at the end of the day, it creates an instance of this incremental change object, which will delegate to the new class from the new dex file from the new class loader. And then it will set the field, the static field in your class to this new object, so that the next time any one of your methods on this class execute, they will find the value of the change field to be not null, and will start delegating the execution to this new implementation. So I guess don't be surprised if you use reflection heavily and you find this $change field there. That's part of instance run. Don't be surprised if you find the application that is in your manifest is not what you expect. That's also part of instance run. Don't be surprised when you see a socket server running in your application. That's also part of instance run. I guess that's it I have for today. Well, thank you very much. And we still have some time for questions. Thank you.
Thank you, Michał. This cold swap stuff just reminded me replacing class files on JBoss server, for instance, on production.
Yeah, these are similar
really
tricks.
Like
and actually, we have an old school Sun engineer on the team who worked on some of the applets.
When the deployment process is so painful, then it's easier to replace one file. You gave us some, you mentioned several times about near future and changes that you are working right now. And the question is, could you give us some roadmap or, like, for instance, goals for this year or some next steps, major ones?
Yeah, also, I hope you can understand I'm just a software engineer on the team, so it's not my job to make any public announcements here today. I can definitely tell you that we keep track of the most, I guess, important themes that we should work on, and build speed is the #1 still, and consistently is chosen by developers to be the most requested feature. Other, I guess, highlights have to do with testing and performance profiling and so on. So definitely we try to track what developers want and act appropriately.
Hey, developers, what you want? Are there any questions? I mean, no marketing as I can see. Okay. Yep.
Yeah, hi Michał, thank you for awesome talk. I have a question regarding my quite a big project where I have several build types and flavors, which leads us to a multiplicated number of variants. Mm-hmm. And what I found, and I constantly do my best to improve the build time of the project because it's a pain, and frankly, and what I currently found spending significant amount of time is that the configuration phase of the Gradle itself. For instance, when I create some custom task for variants, it takes a lot of time. I see that it takes a lot of time to create those tasks, even the tasks for variants which I do not actually want to run. which for instance, I want to build a debug build or a release build, and I see that it creates the whole tree of tasks for debug build when maybe it shouldn't. My question is there any fix for that? I don't know. Maybe there are. I know that it might be the case of the Gradle itself to cache somehow the configuration phase. Is there any way to fix that for now using daemon? Because daemon doesn't cache that.
I mean, so that is mostly, I mean, like at least from our point of view, we like to think that that's the Gradle's problem, not ours. The truth is that Gradle is currently incapable of caching tasks between runs, so that the configuration phase have to run every time. They are actually busy building, let's call it Gradle 3.0, or what they call the software component model, where they want to change the way projects are configured, and they want to have a clear understanding of inputs and outputs to every piece of configuration, and then they want to lazily execute only the pieces that are needed and then cache them between runs. So that is a grand major project within Gradle itself to try to improve it. But for now, and that is what the so-called experimental plugin that we have uses, so you may want to try that, although I think that the performance benefits are still not there. Not at least not fully. On our side, obviously, the variant filter that I showed is, I guess, one way to just trim down the number of variants. So that will obviously remove some amount of work that you do for every variant. And I guess you can try filing bugs. We know we'll now go through a phase of profiling our configuration phase and trying to figure out. We found some surprising bottlenecks there. Like for example, as you mentioned, when you start publishing more than one artifact and so on, you spent a significant amount of time just figuring it out without a good reason for it. So we will try to just get better over time. Yeah, as mentioned, the performance is still #1 priority for us.
Hi. When in your Gradle build you have multiple modules.
Who's speaking? Sorry. Yeah.
Hi. When you have multiple modules in your Gradle build, are those pre-dexed?
Yes. So if you find yourself in a situation where you keep most of your code in a library, then this library gets built in full. The jar gets built on every build, and then this jar has changed then. So that means the whole jar needs to be redexed for your application to deploy. So you may want to consider, I guess, manually slicing your code into smaller libraries so that the fewer dex files needs to be invalidated on every build.
Thank you.
Thanks for the awesome presentation. And to be honest, I and most probably we would like to see you more on stage and not hidden somewhere in the Google offices. That's one thing. Another regarding Jack. So Jack is a server, right? It's run on my Mac or my computer as a server. Can you imagine a scenario when Jack, a compiler, is run on a very fast server somewhere in the office, and every time when I press play or build button, basically my computer, slow laptop, is asking the super fast server to build the code for me and gives me back the artifacts?
I mean, I can imagine such a scenario. I can say I really don't know if they're even considering in the Jack team. That's, I guess, a team that's somewhat separate from Gradle. I know Jack indeed has a server mode that you don't have to use. There is probably a way in Gradle, which I don't know from the top of my head, to actually disable it in your Gradle builds. But yeah, so Jack uses a similar trick where it uses a long-running process to try to take advantage of the JIT compiler and so on. Currently, we take advantage of that, so that the Jack server keeps on running in the background. Whether we could try to actually move the server to a separate machine, that may be actually a good idea, but I don't know anything about it.
Hi. One of the most annoying things before the instant run, for me was that the Android Studio tend to actually run application from some kind of a cache. I don't really know, but when we did some changes and then run the application, sometimes the changes weren't really there, and we used to use the sync Gradle to fix that. It was like a workaround. And on an instant run, it happens kind of a lot for us again, but now the sync doesn't help. And we kind of don't know if it's a known bug or is it a workaround for this. So
Yeah, I mean, if you see any kind of correctness issues, please file bugs just to be sure. I mean, it should never be the case that like you're clicking play and you're not seeing your changes, right? Like no matter what happens, that's not the expected behavior, right? I imagine that one of the reasons for that might be that when you sync, you're executing some kind of dynamic logic. So as mentioned, like if you will put the timestamp in the name of the APK, then Studio will call Gradle and then happily starts using the previously built APK and not the new one, right? That's one option. Studio does keep a cache of what it believes is already installed on the device, so it doesn't try to install the same APK twice if you just decide to rerun your application. So maybe there's a bug in this logic. Yeah, please just file bugs for it. Speaking of which, whenever you file bugs against Studio, the easiest way for us if you create like a little reproducible project on GitHub and just send us a link, because otherwise we spend weeks just exchanging like little snippet of log files and so on. That's not very productive. But obviously some people just cannot share their projects and cannot reproduce the issues externally.
Hey, thanks for the presentation. Our project is heavily based on the components, and my question is whether we can have resolution strategy that will fail on version conflict for our components, which are from the same module, and won't fail for external components. Is that possible to write such logic?
Well, I'm sure it's possible. Like as I mentioned, the Gradle dependency resolution logic is very flexible. The default strategy is whenever you find yourself in a position where through transitive dependencies, you request two different versions of the same library. The default strategy is to use the higher version, assuming the libraries are backwards compatible, which I guess is an optimistic assumption, but let's go with it. You can specify a different resolution strategy, I believe, per configuration. So you could say in compile, whenever there's a conflict, execute this arbitrary logic. And inside this logic, you could say, well, if the coordinate of the package starts with like example, then do something else than otherwise, and otherwise just use a higher version or something like that.
Okay, other question. We had a lot of issues that forced us to use force, to use the latest snapshots, for example, for our internal components, which are used by our second level of components. So, yeah, transitive dependencies. Top level components are using internal components, and apps are built out of the components. And are there any performance gains if we stop using force and try to use exclude and then list the newer version directly of the transitive dependency in the app project itself?
Well, I would imagine you're talking about the actual time it takes to compute the final dependency graph. I don't really know because that's not code we maintain or have written.
Yeah, another annoying issue is that Gradle, let's say that we change the internal component, if I may.
We are running out of time, but yes, let's keep it as the last question.
Okay,
sure.
Thank you. Let's say that we're changing one of the components and release the new snapshot to Artifactory or wherever else. And as a snapshot, it should be marked as changing, right?
Yes.
And let's say that we change the snapshot, then run Gradle sync, and then Android Studio doesn't pick up the changes without running instant run. Is it something that we're doing wrong, or?
So I believe if you in Gradle, if you specify dynamic version of the dependency, like you say just latest, like plus or something like that, Gradle will only check for the new version once a day. So it will not try to download new versions on every single build. So you may be falling victim to this behavior, and there are ways to override it. Well, in such a case, then I guess try filing a bug for us. We may be actually caching things by file name, and then if you don't change the file name of your snapshots, that we may possibly be doing something wrong.
You just heard about 6 times thank you, so instead of saying thank you, I've got something for you.
Oh, well, thank you.
Thank you. Give a nice...
Yep.